Hi, my name is Burham, and this is the 555 time machine in A-stable mode. On the left here is the 555 built with an integrated circuit, and on the right it's the same circuit built with standard components, a dual op-amp, and NOR gates. In this A-stable mode, as the name implies, there's no stable state. This means that it continuously and autonomously produces a square wave visual by these LEDs. So without further ado, here's how the whole circuit works. When the circuit is first switched on, these three identical resistors of 5.1k ohms create reference voltages of 3.3 volts here and 1.6 volts here. These voltages are important for these op-amps, which in this case are being used as comparators. When op-amps are used as comparators, if the positive input is higher than the negative input, the output is high. If not, it's low. So when the circuit's first switched on, this capacitor here has not had any time to charge up, so it's at 0 volts. Both of these are at 0 volts. 0 is not greater than 3.3 volts, so this comparator is low. 0 is less than 1.6 volts, so this comparator is high. This arrangement here of NOR gates is called a set-reset latch. Essentially, it latches onto or stores the given input until it's reset. As we can see from the NOR truth table here, this NOR gate must be low, since anytime there's at least 1, the output's automatically low. So this is low, therefore the LED is on right now, since it goes through a NOT gate. While all this is happening extremely quickly, the capacitor is slowly charging up through these two 10.2k ohm resistors. When the capacitor charges beyond 1.6 volts, this comparator becomes low. This comparator doesn't actually change anything though, since the SR latch is already latched on, and in order for it to change, the set pin must change. Once the capacitor charges beyond 3.3 volts, this comparator becomes high, since 3.3 volts is now less than the voltage presented on the positive input. Now that this is high, the SR latch is set, meaning this output of the SR latch is high, and the LED turns off, since it goes through a NOT gate. Now that this output is high, the transistor is able to turn on, causing the capacitor to drain through this 10.2k ohm resistor to ground. The capacitor continues to discharge below 3.3 volts, turning the set pin back off. Once again, this doesn't change anything since the SR latch is already latched on. Once it charges below 1.6 volts, however, this comparator becomes high, resetting the SR latch. This turns the transistor back off, stopping the capacitor from draining, allowing it to charge again. This cycle repeats again and again, which is what causes the LED to flash until the circuit is disconnected. Thank you for watching this video.